Right, so here we have the data from our investigation. Notice that I've got the table here. I've omitted two columns. I've omitted the potential difference column and the current column, since those were just intermediate steps in calculating our resistance. So remember, the whole point of the practical was to see how the length of the wire affected the resistance of it. Let's think about what resistance is. So remember, electrical resistance is how difficult it is for current to flow through that object. Yeah, an insulator will have an extremely high resistance because it's very, very difficult, if not impossible, to get a current to flow through certain insulators, whereas a wire will have a very low resistance because it's easy to pass a current through it. And it makes sense, I think it probably makes sense, that the longer the wire is, the harder it is to pass a current through it. I've plotted the data into a graph. As you can see, it takes a straight line through the origin. Similar to a lot of our other investigations, it's a straight line through the origin. What does it mean if there's a straight line through the origin on the graph? Well, it's a directly proportional relationship, remember? So resistance, therefore, is directly proportional to the length of the wire in our investigation. So that makes sense, right? So the longer the wire is, the harder it is to pass a current all the way down its length. That's pretty much all there is to it. I do just want to quickly add something to that. So maybe when you did this investigation in class, maybe your straight line of best fit did not go through the origin. Maybe your straight line of best fit might have looked maybe something like this, maybe, I don't know, like that, perhaps, okay? So in that case, clearly it doesn't go through the origin, it goes through somewhere that's not the origin. So that would imply then that at zero length of the wire, there would be some resistance, which kind of doesn't really make any sense. If you've got results similar to that, then it's likely that you've not put your first crocodile clip in the zero position on your ruler. You might have put it a bit further down one way or the other, which would mean that there is actually, at zero length, there is actually some wire there still. This would skew all of your results by exactly the same amount, which is what we call a systematic error. So maybe that's what happened if you did this investigation. If it did, then that's likely the explanation for it.